Hi, this is Phil, back with another video. So in the game Cybenet, I wanted to see if I could add a particle system to allow me to put an additional effect onto the explosions in the game. So I've written a little system here. So this is just a little demo project that I've used to write the code, and so that I can test it before adding it into the game. And I'll show you what this looks like. When I press space here, it'll just randomly add them to the screen. And if I hold that down, you can see what the particle effect looks like. So in the game, whenever there's an explosion, I'm going to add one of these to the same position. So I'll give you that effect. And go to the code. So let's start at the top. So the first two variables, the first one just defines the maximum number of particle systems that I'm going to allow. I've got that set to 100, but in my game Cybernet, there's never more than 100 things exploding on the screen at any one time, so 100 is more than enough for this. Now the max particles is the number of individual particles per particle system. Again, that could be increased quite easily, but I've been playing around with this, and the maximum of 150 gives the right visual effects that I'm looking for. And the next three are arrays, and they're named quite descriptive. So the first one's the status, and if you've seen my previous code, I use this technique just to indicate whether this particle system is live or not. So if it's a 0, that means it's not live. If it's a 1, then I know that it's a live particle system, and I need to update and draw that on the screen. Next two are just the X and Y positions of the starting point for the particle system. And underneath there we have the arrays that look after the individual particles for each particle system. And you can see that these are multi-dimensional arrays. And you can see that so for each one they're the same. So for the status, again, that's the same technique I'm using. So if it's a 0, I don't need to update or draw that individual particle. If it's a 1, then I do. Then we've got the X and Y position of each particle. And then we've got the velocities in both the X and Y directions. And then we've got the lifespan of that individual particle. So that allows us to vary the duration that each particle is on screen. And then the next set of code there is just making all these arrays global and variables, because I'm using these in a procedure. They need to be global so that they can be accessed. And underneath that, I've just got a little game loop there. If you've seen my previous videos, you'll see that I'm using delta time to do the updates, the update calculations. So you can see I've got two go subs. One does the updating of the particle system and one does the drawing. And then just for this demo, I've got a function there that's just capturing the spacebar. When that's pressed, it calls the function. So this is the I keep saying function, but yeah, it's a procedure. This calls a procedure that will put an individual particle system on screen at a random X and Y position, and this is the number of particles it'll add. So this just gives me a number between 50 and 150, and then 60 is the lifespan of the or the maximum lifespan of each individual particle. So if we look at the add particle system procedure, so you can see there the input variables, self-explanatory. So the first thing I'm doing there in this first outer loop, I'm looping through the array of particle systems, trying to find one that's set to 0. So the first free array element, I'll use that. First thing I do is set that to 1 so it's not reused, and so that I know that that's in use. And underneath there, we're setting the X and Y position of the particle system. So that's really the source of where the particle system will start. I'm not actually using that anywhere else, but this I'm probably going to extend this system in the future, and I might have a particle system where individual particles keep getting added to the system over time. And if that's the case, you may need to know what this X and Y position is, so they can position the individual particles when you're adding new ones to the system. So that's why I've left those there. The next for loop takes care of adding the individual particles for the particle system. So it's the same technique. I'm looking at the status of each particle array element. So the first one that's a 0, I then check the particle count, and if that is greater than 0, I then set up the array elements for that individual particle. Now every time I add one, I decrement the particle count, so that once we've added the right amount of particles, we then just set the rest of the status arrays elements to 0. So we're only basically, by the end of this array will just have the right number of particles set to a status of 1, and the remainder will be all zeroed out. So the individual arrays are there, setting the status, setting the X and Y position, and the velocities are randomly generated. So this will give us a value between -300 and +300. So that'll give us the effect of everything moving away from the source X and Y position that's passed in here. This could be passed in as a parameter into the procedure if you wanted to do that, but for my use case here, I might change that in the future, but I've just hard coded them in there for now. And then, as you can see there, the life of each particle is set to the random max life that's passed in. So for my example here, I'm passing in 60, so that'll give me a random number between 0 and 60 for the individual particle. So that just sets up the particle array, and then in the update particle, I'm looping around all the particles systems. When it finds one that's set to 1, so it's live, I'm just setting this variable here, setting this to 0. I'll come back to that in a second. So what it'll then do, it'll loop around all the individual particles, and if it comes across one that's a 1, it will then update the X and Y position using the velocity that's been set, and you can see them using the delta time for that calculation. So that updates the X and Y, and then I also reduce the life of the individual particle, and I'm using this calculation to do that. And so underneath there, I'm just checking if the life of this particle, if it's less than equal to 0, then I'm setting the status. That means that it needs to be removed, so I don't need to draw and update that anymore. So I'm setting it to 0 there. And if we go back to this has live particle, if this for loop has completed without dropping into this part of this if else, that will tell me that there's no particles with a status of 1. So that's just a flag that I'm using so that I can then set the particle system status back to 0 to free that up for another one. So that's all that little bit of code is doing. So that looks after updating the particle system, and the draw is pretty simple. Again, looping around the particle system array, and then once it finds one that's live, it'll loop around all the particles, and when it comes across one that's a 1, it's just doing a plot. So it's literally just putting a pixel on screen with a colour of 1 at the X and Y position. Now you could change this colour, you could have this, it could be a random range of reds or, different shades of bluey white to give you a different effect. I may do that in the future, but for now I'm just putting them on as colour 1. And that's it really. Again, this is just one effect, but what you could do is create a different add procedure to set up your variables in a different way to give you a different effect. So what I'm thinking of doing in the future is having a similar thing where when something's damaged, it can be emitting sort of some smoke. So again, I can use a very similar setup to get that effect. So this is for the explosions. Now let's see how that looks in the game. So you can see when the ships explode, you get that particle effect. It just adds a little bit of extra polish to the game. And I think it just makes it look a little bit nicer. Alright, thanks for watching. Hope you've enjoyed that. And I'll be back again at some point.